Good day everyone, we are from the second group. Today we are going to introduce to you the different topics like geometric sequence, geometric series, geometric mean, sum of the first n terms, and infinite geometric sequence. Sit tight and listen carefully. Let's begin.
In mathematics, a geometric progression, also known as a geometric sequence, is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed, non-zero number called the common ratio. What is common ratio? The common ratio is the amount we multiply by each time in a geometric sequence. How do you find the common ratio? You can determine the common ratio by dividing each number in the sequence from the number preceding it. If the same number is not multiplied to each number in the series, then there is no common ratio. Thus, having the formula a sub n equals a sub 1 multiplied by common ratio raised to the power of n minus 1.
Example number 1. Find the 10th term of the following geometric sequence: 9, 3, 1, 1/3, and 1/9. Here are the given. A sub 1 is equals to 9, a sub n is equals to a sub 10, n is equals to 10, and r is equals to 1/3. The formula we are going to use is a sub n equals a sub 1 times r raised to n minus 1. After substituting our given terms to the formula we will be using, we have now a sub 10 equals 9 times 1/3 raised to n minus 1. After calculating in the proper order, we will have the final answer. A sub 10 is equals to 1 over 2178.
Did you understand well the geometric sequence and its formula? If so, let's dive into another topic, which is geometric series.
What is geometric series? Geometric series are used throughout mathematics. They have important applications in physics, engineering, biology, economics, computer science, queuing theory, and finance. Geometric series are one of the simplest examples of infinite series with finite sums, although not all of them have this property.
The two types of geometric series. The first one is the finite geometric series. When we sum a known number of terms in a geometric sequence, we get a finite geometric series. It is a sequence of numbers related by some rule. The number of the numbers in the sequence is finite or limited.
And the other one is infinite geometric series. When the common ratio is greater than 1, the terms in the sequence will get larger and larger. And if you add the larger numbers, you will not get a final answer. The only possible answer would be infinity, and is a sequence of numbers which does not terminate.
Okay, so now we are done with our first one. Next, we'll tackle about the geometric mean. It is a mean or average that indicates the central tendency of a typical value of a set of numbers by using the product of their values. To understand this better, we have here more detailed descriptions and instructions of a geometric mean.
Geometric mean. The geometric mean is a type of average usually used for growth rates, like population growth or interest rates. A term between two terms of geometric sequence is a geometric mean of two terms. Involves roots and multiplication, not addition and division. You get geometric mean by multiplying numbers together and then finding the nth root of the numbers such that the nth root is equal to the amount of numbers you multiplied. Here are the geometric mean formulas. X is equal to square root of AB, or a sub n is equal to a sub 1 multiplied by r raised to n minus 1.
Now, here's our sample problem. Number 1. What is the geometric mean of 4 and 9, given our first term is equal to 4 and our last term is equal to 9. The formula that we're gonna use is x is equal to square root of AB. Solution: x is equal to square root of AB, and we will substitute our first term and last term, where x is equal to square root of 4 times 9. After substituting, multiply the first term and the last term, and we will get the answer square root of 36. But that is not our final answer. We need to solve the square root of 36 for us to get the geometric mean. And after we solve, we will come out x is equal to 6 as our final answer.
Fun fact: who discovered geometric sequence? Carl Gauss was born in 1777 in Germany. As a 10 years old, Gauss discovered the geometric formula for sequences. As Gauss grew older, he didn't stop there. He continued to discover geometry as well as other mathematical studies. As the story goes, when Gauss was a young boy, he was given a problem to add the integers from 1 to 100. Remember that there were no calculators those days. As other students struggled with these lengthy addition problems, Gauss saw a different way to attack this problem. He listed the first 50 terms, and then listed the second 50 terms in reverse order beneath the first set. You can think of it as he wrapped the series back onto itself. We have finished the discussion. Did you understand it? Well done! Next we have our fourth topic, which is the sum of the first n terms of a geometric sequence.
If a geometric sequence has first term a sub 1 and common ratio r, then the sum of the first n terms is given by s sub n is equal to a sub 1 open parenthesis 1 minus r to the power of n over 1 minus r, where r is not equal to 1. Sum of the first n terms. We now have derived a formula for calculating the sum of the first n terms of a geometric sequence.
Now, we'll show you some sample problems. The first problem is, find the 8th term of the geometric sequence, negative 2, 1, negative 1 half, and 1 fourth. First, let's list the given. A sub 1, or the first term, is negative 2. The common ratio, or r, is negative 1 half. The formula we will be using is Sn is equals to a sub 1 minus a sub 1 times r raised to the power of n over 1 minus r. After substituting, we will get S8 equals to negative 2 minus negative 2 times negative 1 half raised to the power of 8 over 1 minus negative 1 half. Then we will solve. After solving, the result will come out as negative 85 over 64.
Last but not least, the infinite geometric sequence.
An infinite series that has a sum is called a convergent series.